First question on the practice test for Math 1230, asking us to simplify an expression after plugging in 4. So, if 4 is, I'll replace all the x's with 4, so we'll have 2 to the power of 2 times 4, so 8. 8 minus 4, we'll have a 4 there, to the power of 4, and then plus log base 4 of the ln of e to the power of 4 times 4, so 16. Okay, now going, we have the square root of 2 times 4, so that's 8, multiplied by another root of 4. And keep going. This is 2 to the 4 is 16, so we have a root of 16 there. We have plus log base 4 of ln e cancels, cancellation law, and we have a 16 in here. Minus the square root turns into the root of 8 times 2, so root 16. Okay, we have a negative root 16, positive root 16, those are going to cancel. So we have one piece, log base 4 of 16. Well, 16 can be written as 4 to the power of 2, 4 squared. We have another cancellation law, log base 4 of 4. That cancels, we just have the power that's left, power 2. So choice B. Okay, next one. Nasty exponential expression to a negative fractional power. The way we're going to solve this is simplify what's inside the bracket first, or use the negative power first. I can use a negative power as a first move. You don't have to do that. You can absorb the negative power into flipping top and bottom. So this will turn into 27 a to the negative 3 over 2 times x over 8 a to the 9 over 2 x to the negative 8 to the power of 1/3. Okay. Now I'm going to simplify what's inside. 27, I'm just going to leave it alone. We have a to the negative 3 over 2 upstairs and a to the positive 9 over 2 downstairs. We have a to the something divided by a to the something else. The powers are going to subtract. It'll be this top power minus the bottom power. So minus 3 over 2 minus 9 over 2. Okay, and for the x, we'll do the same thing. I'll bring the x stuff up. We have x to the power 1 minus 8. We're subtracting the bottom power. It's already negative, so we're going to subtract the negative. And that's all to the power of 1/3. And we're missing the 8. So there, we're going to bring the 8, keep that down there. Okay, now keep simplifying. Keep going. 27. And then 3 over 2 minus 9 over 2. The denominators are the same. That'll be negative 12 over 2, which is negative 6. So we have a to the negative 6. And then x to the 1 minus 8, that's x to the 9, divided by 8 to the power 1/3. This power 1/3, I'm going to distribute each piece inside this expression. They're all being multiplied together, so it's safe to do that. If any of these are being added, we couldn't do that. So we'll have 27 to the 1/3 times a to the negative 6 to the 1/3 times x to the 9 to the 1/3, all divided by 8 to the 1/3. And then simplify each one. Cube root of 27 is 3. Now this one, we have a power to the power. The powers are going to multiply. Negative 6 times 1 over 3 will be negative 2. So a to the negative 2. And then 9 times 1 over 3 will be 3. So x to the 3. And then cube root of 8 is 2. Okay, we look at the options. None of the options look exactly the same. But if we rewrite this a to the negative 2 as a to the positive 2 downstairs, we'll get a match. 3x cubed over 2a squared. So choice E. Okay, next one. Simplifying this log expression. Log of something minus log of something else. So one rule we're going to need to use is ln of A minus ln of B is the ln of A divided by B. Let's use that rule. And then downstairs we have e to the ln of x and e to the 2 ln of x and e to the 3 ln of x. So we have to use another rule there. I'll put that one right here. That c times the ln of a equals the ln of a to the c. So the power, the number in front of a log function can be brought up as a power inside. And we do the reverse sometimes as well, depending on what we're trying to do. Okay, so here we go. On top, I'm going to take the ln of the first minus the ln of the second as the ln of first divided by second. So ln of x e to the 8x divided by x e to the 4x. And downstairs, we have e to the ln of x to the power of 2 multiplied by e to the ln of x to the power of 3. So we're bringing those powers up. Well, this cancels. Eln cancels. This eln cancels. This x cancels and that x cancels. So we'll get something that looks a little bit nicer. Ln of e to the 8x over e to the 4x divided by x squared times x cubed. Okay, getting close. Now we have another exponent law. E to a power divided by e to a different power. Those powers are going to subtract. We'll have ln of e to the 8x minus 4x all divided by x to the power of 2 plus 3. Ln e cancels. We have 8x minus 4x. That'll be 4x upstairs over x to the power of 5. And we can cancel one power of x. So we have 4 over x to the power of 4. Pretty nasty. Okay. Second page, number 4. We're asked to solve for x that's trapped in an exponential expression. And it looks like it's impossible to do. But it's not. Because this is 5 times e to the 2x, and this is 6 times e to the 2x. We can combine these two pieces together. They're 5 times something and 6 times the same thing. So if we start by subtracting, let's say, 5e to the 2x from both sides, then the expression is going to be 8 to the power of x plus 2 equals 6e to the 2x minus 5e to the 2x will give us 1 multiplied by e to the power of 2x. So that's subtracting from both sides. Now we can do the usual thing. If an x is trapped in a power of an exponential function, we can take the log of both sides of the expression. I can use a natural log. Ln of 8 to the x plus 2 equals the ln of e to the 2x. Now there's a cancellation law there, and on the left side we can bring our power down. So x plus 2 times the ln of 8, being very careful that the whole power that comes down multiplies by ln 8. And then on the right, we just have 2x. Now I'm going to multiply the ln of 8 into the bracket. So we'll have x ln 8 plus 2 ln 8 equals 2x. Let's keep going. Let's group all the x stuff to one side. I'm going to subtract 2x from both sides. So x ln 8 minus 2x, and then subtract 2 ln 8 from both sides. Now common factor the x on the left. X times ln 8 minus 2 equals negative 2 ln 8. And then divide both sides by the stuff that's multiplied by x. So negative, x is negative 2 ln 8 over ln 8 minus 2. Negative 2 ln 8 over ln 8 minus 2, so b. Now, there's a problem with this one in that this step here, you could have also subtracted 8 ln of x from both sides and then rearranged slightly differently. If you do it that way, you'll get 2 ln of 8 upstairs and then negative ln 8 plus 2 downstairs, which is equivalent. You multiply top and bottom by negative 1, you'll get that. Multiplying top and bottom both by negative 1 won't change the answer. Anyway, next one. Solving for x here. We have an exponential function with an x trapped in the power. It's not wise to take the log of both sides right away because the exponential function is multiplied by something. So I'm going to start by dividing both sides by 100. 500 divided by 100 is 5. So we have 5 equals 5 minus e to the power of 4x. Now it's safe to take the log of both sides. Or not, it's always safe to do so, but now it's going to be easier. Okay. And we bring the power down. So ln of 5 equals 4x times the ln of 5 minus e. Well, we're almost done. We just have to isolate for this x here. So we're going to divide by 4, both sides, and divide both sides by this number, ln of 5 minus e. So we'll get x equals ln 5 up on top divided by 4 times the ln of 5 minus e. And do we have that? Ln 5 over 4 times ln 5 minus e, so choice A. Okay. A6. We're looking for the derivative of this function. So this is a b to the w minus the ln of w, or I'll put a u there, so I don't want to use w twice. When you take the derivative of b to the w, you get b to the w times the ln of b times w prime. When you take the derivative of ln of u, you get u prime over u. If it was w, it would be w prime over w, whatever letter you like. So according to this formula, or these formulas, the derivative of f prime of x will be b to the w times ln of the base times w prime. So we'll have 3 to the x times the ln of 3 times 1. The derivative of 1 times x is just 1. I'll have to write that. And then minus u prime over u. So the derivative of what's inside here, derivative of x to the 9 is 9x to the 8. And then downstairs we have u, the original function that's inside, so x to the power 9. We get some cancellations happening. 3 to the x ln 3, that part doesn't change. The second part, 9 over x. 8 powers of x upstairs, 9 downstairs, 1 is left downstairs. And that's going to be D. Okay, last one on this page. Looking for the derivative of this function, and once we take the derivative, we want to plug e in for x. In order to take the derivative, we have to recognize that this is a product rule. This first piece here has two functions a and b multiplied together, and then minus another derivative, the derivative of this piece separately, not involved in the product rule. So first, the derivative f prime of x will have a times b prime plus b times a prime for the derivative of this part, and then minus the derivative of that part, 4x to the power of 3. Okay. A is 4x to the 4. Ln of x, when we take the derivative of that, we get 1 over x. And then plus b, which is ln of x, times the derivative of 4x to the 4. So we'll get 16x to the 3. Then we have minus 4x to the 3. That was hanging out from the beginning. Okay, some good stuff happens. X to the 4 up here, and 1 power of x downstairs. We're going to get the partial cancellation of powers. We'll get 4x to the 3. Plus, and as is tradition, I'll put the number first, x power second, log function third, and then the piece that was all by itself can finally join in the rest of the function and cancel out. first piece. So that's our derivative. F prime of x is 16x cubed times the 1 of x. Now we're going to plug e in for x. So we get 16e to the 3 times the 1 of e, which is 16e to the 3 times 1. And since ln of e is 1, and that's choice B. Okay. Next one. A8. Determine the first derivative of this function. This looks like a nasty mess. This is a regular chain rule. This is a function w to the power of 5. When we take the derivative of that, f prime of x, we're going to have 5 times w to the 4 multiplied by w prime. So if we don't see w to the 4, we can kind of throw away the answer. This is not w to the 4. This is something that this is some other thing to the 4. So this is useless. W with the power 5 still on it. That ain't good. W with the power 4. Okay, that one fits, and so does the one above. And this one has a power 5 on it instead of a power 4, so it's also no good. So we're stuck between A and D. We have to do it. Okay, so we get 5. Put the original function in. The original function is 6 minus log base 3 of 7x plus 2, all to the power 4. And then we multiply by the derivative of what's inside. The derivative of 6 is 0. The derivative of log base 3 of 7x plus 2, we used a similar formula on the last page. The derivative of ln of this would be, if we call this inside thing here u, we get u prime over u. But because there's a log with a base of 3, we're going to get u prime over u ln 3, ln of the base, where u equals 7x plus 2. So u prime is 7. So we'll get 5 times this stuff, 6 minus log base 3 of 7x plus 2, all to the power 4, multiplied by negative 7 over 7x plus 2 ln 3. So the ln 3 is downstairs, choice D. Now the 35 comes from multiplying the 5 times the negative 7, and then bringing this piece downstairs underneath. So just multiplying those two things together. Okay, number 9, much more friendly looking. We have an e to the power w function. So the derivative f prime of x is e to the w times w prime. So we'll have e to the x squared minus 5x multiplied by the derivative of x squared minus 5x, which is 2x minus 5. Now it says to plug 6 in for x. So f prime of 6 will have e to the power of 6 squared, which is 36, minus 5 times 6, which is 30, multiplied by 2 times 6, 12, minus 5, so 7. And then we'll clean that up. The number usually goes in front. And e to the power 36 minus 30, e to the power 6. So choice A. Okay, 10. Logarithmic it says, what is the derivative of the function? Hint, you must use logarithmic differentiation. Well, isn't that nice? There's a hint, but you can't rely on always getting that type of a hint. The hallmark of a logarithmic differentiation function is when the base contains x in it and the power contains x in it. It's not an exponential function, and it's not something that behaves like a polynomial. It's kind of both at the same time. And you don't have a nice derivative rule for those. again, if there's x stuff in the base and x stuff in the power, then you have to do what I'm about to write. You have to start by taking the log of both sides. So I'll use a natural log as the easiest one. Ln of y equals the ln of e to the x plus 1 to the x. We bring the power down using the usual log rules. Okay, so that's what we have now. And now it's ready for derivative. So we're going to take the derivative of both sides. On the left, this is like a ln of w. We get w prime over w, except it isn't w, it's y. So y prime over y equals, and on the right we have a product rule. We'll have a times b prime plus b times a prime, where a is equal to the x, so a prime is 1, and b is equal to the ln of e to the x plus 1. So b prime is going to be u prime over u. We'll have the original function u downstairs, and then the derivative of the original function upstairs. The derivative of e to the x is e to the x. Derivative of 1 is 0 because 1 is a constant. So we got e to the x over e to the x plus 1. Okay, now I'm going to zoom out. I have to plug all that stuff in. I'm going to put some more space in there. So put the a, which is x, times b prime, which is that giant mess, e to the x over e to the x plus 1, and then plus b, which is a log function, ln of e to the x plus 1, multiplied by a prime, which was 1. Okay, we could answer the question at this point, but I'm just going to clean it up. Y prime is equal to y multiplied by all that stuff that's up there. X times e to the x is x e to the x. And we have e to the x plus 1 downstairs, and ln of e to the x plus 1 is the second term from that product rule. And finally, we can replace y with what it was originally, this function, e to the x plus 1 to the x, and then write in all that other stuff. So everything that's above inside that square bracket, stick it back there. So that looks like D. Okay. All right, now we're getting multivariable stuff. And this first multivariable question is asking us to evaluate the function at an x, y, z coordinate. So f at, I replace the x with e to the 3, replace the y with e to the 4, and the z with e to the 5. So now be careful. This first one is x squared, so e to the 3 squared multiplied by y multiplied by e to the 4, and then plus z squared. So that z is e to the 5, and that'll be squared, all divided by the ln of x squared, so e to the 3 squared, multiplied by y squared, which is e to the 4, all squared. Okay, we'll clean this up. E to the 3 to the 2, the powers are going to multiply. We'll get e to the 6 times e to the 4 plus e to the 5 times 2, e to the 10. And then downstairs, we'll have the ln of e to the 6 times 4 times 2, e to the 8. Use some exponent laws. E to the 6 plus 4 is e to the 10. We have e to the 10 plus e to the 10. We're going to get 2 e to the 10. And then downstairs, we have the ln of e to the 6 plus 8. Powers add, and that will cancel. So we'll have 2 e to the 10 over 6 plus 8, 2 e to the 10 over 14. So I'll write that down, 2 e to the 10 over 14. We can reduce that fraction. 2 over 14 is 1 over 7. So e to the 10 over 7. Choice B. Okay.